This video will cover the basics of angles. So in the vocab video, we introduced a ray. So if I introduce that ray again, so some ray, we have an endpoint and it extends out. If there's another ray that shares a common endpoint, or it shares this origin point, we have just created an angle. And the measure of that angle is telling you how far of a rotation you need to make to get from this original angle, or sorry, this original ray to this new ray. So if we're trying to figure out how much do I need to rotate to get to that point, that rotation, which is in degrees, and there's another way to measure an angle, but you can learn about that in another class. This equals the angle's measure. Okay? Now, how do we label this thing? So a ray needs 2 points to be described, right? We discussed that before. So let's say that this point is A, its origin is B. This other ray also originated at B and has another point C. So the way we would label this angle is one of two ways. We can call it angle ABC. So using 3 letters, and this will be important in certain scenarios, where the middle letter always serves as the vertex or the origin between those 2 rays. So the vertex of the angle or the origin of the 2 rays. Or if this is a standalone angle and there's no other angle that shares vertex B, we can just simply name the angle by its vertex. So we can just call it angle B. The scenario where you would have to use 3 letters is if the following occurred. Let's say I extend another ray from B. Now if I reference just angle B, you don't know which of the 3 angles that are here that I'm talking about. Are you referring to this angle? Are you referring to this angle? Or are you referring to the whole angle? Because you don't know, it's important that if a vertex is shared between more than one angle, you use 3 letters to name your angle. Now, if we are told 2 angles are congruent, then we know things about their measure. So if I draw 2 congruent angles to the best of my ability, let's call this A, B, C, and this D, E, F. One way we can be told that these angles are congruent is if you see arcs in the angle. So this has a single arc, and this is accompanied by a single arc. That is indicative that the following is true. We can jump to the conclusion that angle ABC is congruent to angle DEF when we see that arc. Okay, and if 2 angles are congruent, that means that their measures are equal. So we can write the measure of ABC is equal to the measure of angle DEF. Just like there was a segment addition postulate, there's also an angle addition postulate. So the angle addition postulate tells us, just like the segment addition postulate, that the sum of the parts equals the whole. So if we have this large angle PQR, if there's S, some point S that's on the interior of this angle, so let's point S, there is a ray that can be drawn from Q through S. We have now divided our large angle into 2 subangles, and the angle addition postulate, as you might expect, tells us that the measure of angle PQS plus the measure of angle SQR should equal the measure of the entire original angle PQR. And this is the angle addition postulate. So if you see this formatting in a problem, you need to be able to recognize that that is this postulate. And we can use this to figure out lengths of measures of subangles. Like if I know the entire angle's measure and I know one subangle, I can find the other subangle using this basic idea. Now, if it just so happens that this point S was in a position and where it divides this angle into 2 equal subangles, we can call that ray QS the angle bisector. So again, if we introduce S in a location where that ray creates a congruency between the two subangles, then we can say that QS, or ray QS, is the angle bisector to angle PQR. Remember, bisector means cut in half, so we can now say, as a result of this, that the measure of angle PQS is equal to the measure of angle SQR. And if their measures are equal, they're congruent. So you could have also said that PQS is congruent to angle SQR. Now that we've established what an angle is, let's look at special pairs of angles. So the first thing we're going to look at is adjacent angles. Adjacent means next to. So really simply put, there are two angles that share a ray. So for example, angles 1 and 2 are adjacent. Because they are sharing this ray. However, angles 1 and 3 are not adjacent because they do not have any rays in common. So that is the only condition that you need to look for if I ask you to identify adjacent angles. Do two angles share a ray? Now, a special case of adjacent angles will be when those two angles happen to form a line with their non-shared sides. So what do I mean by that? Let's say we have 1 and 2 are adjacent to each other. But in this scenario, the non-shared sides of these two, so this ray here for angle 1 and this ray here for angle 2, form a line. So its measure is 180 degrees. When the non-shared sides form a line, we refer to angle 1 and angle 2 as a linear pair. And that name gives it away. If I ask you to identify a linear pair, you know that the non-shared sides form a line. So non-shared rays or sides of the angle, of the adjacent angle, form a line. Or I should say, maybe even more simply put, a straight angle. Now, it's important to note that a linear pair has to be in a pair of adjacent angles. So we cannot say that the following is a linear pair. Let's say I am drawing even though angles 1 and 3 form a line with these two sides, they don't share a common ray. Therefore, because I can't classify 1 and 3 as an adjacent pair to begin with, or adjacent angles to begin with, they don't qualify as a linear pair. Another good way to identify a linear pair, because it's a pair, we know I'm only dealing with two angles. This linear pair, the measures sum to 180 degrees. So that's a good check as well. So if you think you have a linear pair, the angle measures should sum to 180 degrees. And the last two angle pairings you need to know are what we call complementary and supplementary angles. So complementary angles are two positive angle measures that sum to 90 degrees. So these two angles will form a right angle. Supplementary are two positive angles that sum to 180 degrees. Okay, so complementary, they form a right angle. Supplementary form a straight angle. So let's say that we have some angle measure x. The way you find its complement is you do 90 minus x, because the two angles should add up to 90 degrees. So if we have x, 90 minus x serves as the complement. If we have some angle y and we want to find its supplement, we do 180 minus whatever that angle measure, which is denoted as y, is. So this serves as the supplement. And those are all of the special angle pairings we need to know for now, as well as, I should say, an introduction to angles. Actually, I almost forgot about one pair. The final pairing is actually vertical angles. Vertical angles are the opposite angles that are formed when two lines intersect. So if I have a line and another line, there are four angles that are formed. The angles opposite one another, so the ones that don't share any rays, those are what's considered vertical angles. So angle 1 and angle 3, angle 2 and angle 4. These are vertical. And what you might expect as well is that vertical angles share the same measure. So angle 1 and angle 3 are equal in measure. Angle 2 and angle 4 are equal in measure. So vertical angles, measures are equal. Okay. And just as a quick recap, we can see that 1 and 2 in this case would form a linear pair. 3 and 4 are a linear pair. 1 and 4 are a linear pair. 2 and 3 a linear pair. So there are many possibilities for special pairings. Be able to recognize all of them. And that will be the conclusion for the angles introduction.